Welcome to Site Reliability Engineering Crashcasts. I'm Sheila, and today we're diving into the world of highly available systems. We'll explore different approaches to designing these systems and learn from some fascinating case studies. Joining me as always is our SRE expert, Victor. Hey, Victor, ready to make reliability exciting?
Hey, Sheila, absolutely. Reliability might sound dry, but it's the backbone of every successful tech company. Let's make it thrilling for our listeners.
Before we jump in, listeners, you'll want to be familiar with basic concepts like servers, networks, and databases. Now, let's kick things off with a quiz question. In 2013, Amazon.com experienced an outage that lasted just 49 minutes. Any guesses on how much money they potentially lost during that short time?
Ooh, that's a great question, Sheila. It really highlights the importance of high availability. Think about it, folks. Amazon is a global e-commerce giant, processing countless transactions every second. Even a minute of downtime can have massive repercussions. I won't spoil the answer, but I bet it's more than most of us make in a year.
You're right, Victor. It's a staggering amount that underscores why highly available systems are crucial. So, let's start with the basics. What exactly do we mean by highly available systems?
Great question. A highly available system is one that's designed to be operational and accessible nearly all the time. The goal is to minimize downtime and ensure that the system can handle failures without significant disruption to users. Think of it like a backup goalkeeper in soccer, always ready to jump in if the main keeper gets injured.
That's a helpful analogy. So what are some common approaches to achieving high availability?
The two most fundamental approaches are redundancy and load balancing. Redundancy means having backup components ready to take over if the primary ones fail. Load balancing distributes incoming requests across multiple servers to prevent any single point of failure. Together, these form the foundation of most highly available systems.
I see. So if I understand correctly, redundancy is like having spare tires for your car, while load balancing is more like distributing weight evenly in a truck to prevent it from tipping over.
Exactly, Sheila. Those are spot-on analogies. Now, as we move to more advanced concepts, we start talking about fault tolerance and disaster recovery. Fault tolerance is the ability of a system to continue functioning when a part of it fails, like a car that can still drive even if one tire goes flat. Disaster recovery, on the other hand, is about how quickly you can get back up and running after a major failure.
That makes sense. Can you give us an example of how these concepts are implemented in the real world?
Certainly. Let's look at Google, known for its incredible reliability. They use a distributed system approach, spreading their services across multiple data centers worldwide. This provides both redundancy and load balancing on a massive scale. If one data center goes down, traffic is automatically rerouted to others.
Wow, that's impressive. Are there any common pitfalls or misunderstandings when it comes to designing highly available systems?
One major pitfall is focusing too much on hardware redundancy and not enough on software resilience. Another is neglecting the human factor. Even the best designed system can fail if operators aren't properly trained or if processes aren't well documented.
Those are great points, Victor. Now, I've heard that some companies aim for 5 nines of availability. What does that mean, and is it realistic?
5 nines refers to 99.999% uptime, which translates to just about 5 minutes of downtime per year. It's an extremely high standard that's very challenging and expensive to achieve. For most companies, 3 nines, 99.9%, or 4 nines, 99.99%, is more realistic and still provides excellent availability.
Thanks for clarifying that, Victor. Before we wrap up, here's a fun fact. Google's overall availability is so high that you're more likely to get struck by lightning than experience a Google outage.
That's incredible, Sheila. It really puts things into perspective. And speaking of perspective, remember our quiz question about Amazon's 49-minute outage? Well, it's estimated that Amazon potentially lost around $4.8 million in sales during that brief downtime. That's over $98,000 per minute. It really shows how critical high availability is for big tech companies.
That's mind-boggling, Victor. To wrap up, let's summarize the key points we've covered. Point 1. Highly available systems aim to minimize downtime and ensure continuous operation. Point 2. Key approaches include redundancy, load balancing, fault tolerance, and disaster recovery. Point 3. Real-world implementations often involve distributed systems across multiple data centers. Point 4. While perfect availability is impossible, companies strive for 3 nines to 5 nines of uptime. Point 5. The cost of downtime for major companies can be astronomical, emphasizing the importance of high availability.
Excellent summary, Sheila. Remember, listeners, high availability isn't just about technology. It's about ensuring that your users can always access your services when they need them.
Absolutely, Victor. And that brings us to the end of today's Crashcast on highly available systems. If you enjoyed this episode, please subscribe to Site Reliability Engineering Crashcasts and leave us a rating. Your support helps us keep bringing you bite-sized SRE knowledge. Until next time, stay reliable.